We know the grid is undergoing massive change, which creates massive opportunities for local energy. The Energy Changemakers podcast offers rich conversations with industry leaders to help you and your company capture opportunities to build a decentralized grid. I'm your host, Elisa Wood. Welcome to the Energy Changemakers podcast. Hey, everyone. Today we're talking to Steve Pullins, the former Chief Technology Officer at AlphaStructure, one of Schneider Electric's microgrid divisions. While there, he played a key role in several of their marquee projects, including the well-known JFK Airport microgrid and the Montgomery County, Maryland microgrid projects. He's been in the distributed energy space for years, and I've been talking to him for years. And I enter every conversation with great curiosity because Steve is always opening up new possibilities, doing something on the edge, something that hasn't been done before or not done in this way. And Steve Pullins is at it again. Now his newly formed company, ResSET, is working on a sustainable multifamily building, but not just any sustainable multifamily building. This one is going to be off-grid, which is very unusual in the US, but particularly for an apartment building in an urban setting. It's part of a small but growing trend toward using off-grid power, particularly where electricity prices are high or grid power is unreliable. But I'll let Steve fill you in. Hello, Steve Pullins, and welcome to the Energy Changemakers podcast.
Yes.
So last time we spoke, we've spoken several times, but last time I really interviewed you, I think it was about the JFK microgrid project that you were working on, which is a pretty complicated, sophisticated, really unusual microgrid, a lot going on there, and big commercial microgrid.
Yes.
Microgrids, right? Microgrids, there are multiple. Yeah.
Right. Federated microgrids. Yes.
That's right. You introduced me to that term, federated microgrids. Exactly. So now it strikes me that you've kind of like gone the other way to residential this time. It's a multifamily housing complex. So we're not talking about a home, but
Right.
still it's residential. So tell me, what was your thinking? Why did you decide to take on this particular project?
Basically, because a longtime friend asked me. And it sounded interesting, and the objectives were still in the formulation stage. And I thought that I could come in and help bring some thought to the situation that would be helpful to the site owner and eventually the residents of that site. And, it's a pretty interesting scenario. It's in Ann Arbor, Michigan. It's a multifamily facility that's being built or will be built. It's, gathering all the capital right now and finishing up the construction drawings and things like that. So groundbreaking is planned for March of 2025.
Oh, not too far away.
Not too far away, really. And that's just around the corner.
Right.
So the thing that was going on was the owner really wants to create a nexus of affordable, sustainable, resilient living. And there's been, a couple things. Ann Arbor is primarily powered by DTE Energy.
Which is the local utility.
Local utility in Michigan. So it's an investor-owned utility. And there's a history there in Ann Arbor of extended outages. So when there is an outage, and outages aren't frequent, but when they happen, they're always at the wrong time and they're usually pretty devastating to businesses as well as residents.
So I'm guessing this is Michigan, so it's probably winter kind of outage, correct?
That's right. That's the argument. The argument is when it's 30 below outside and you lose the grid, that's an emergency situation.
Mm-hmm.
And so one of the challenges was the local rules. So the laws of the land, the city ordinances and that say that you need to evacuate the building in an emergency. Okay. So if you're going to build a facility that's 8 stories tall, it's got 225 residences. And if you have a fire, you definitely want the people out. That's true.
Hmm.
But if you have, a loss of grid or a major weather event that's outside where you're taking people and you're putting them actually into harm's way by evacuating a building, that's just not in keeping with the overall objectives of the owner.
You're creating a disaster by putting people out in cold.
Yeah, you're taking a bad situation and you're putting people at risk by
Hmm.
by doing this. And then finally, the sustainability aspect. So affordability, sustainability, and reliability and resilience. There's a huge need in Ann Arbor for new residences. Today, they're short by like 10,000 residences. And the projection between now and 2030 shows the growth of the city. It could be as much as 80,000.
Wow, and that's not a big city, so that's a lot of lack of housing.
Yeah, the truth is it's kind of typical for a mid-sized city in the United States where there is renewal of jobs and there's growth of jobs and there's even migration, right? So the urban migration that we see globally moving into cities and expanding cities, and that, the second tier cities, those medium sized cities, they see it too. So
Hmm.
it's not just the New York cities and the LAs that are growing, it's also the smaller cities, meaning smaller, meaning let's say the 100 to 200,000 or 300,000 person cities. But so there's this shortage that's current and getting worse over time, and that's causing prices to be pretty high. And we see that one of the challenges in the United States, post COVID, is the cost of living is increasing, and we see that in our groceries and we see that in our housing. So there's a need there.
Hmm. It's not
And
low income housing that you're building, though, right?
so,
It's
well, it's a mix. So it is a portion of it, about 35-40% counts as low income housing. So if you were to look at the medium income, it would be targeted for folks who are in the 60 to 80% of medium income.
Mhm.
Okay. So it's lower income housing. And then the rest of the apartments will be at market. Okay. And that's part of the negotiation that has taken place with the city for, the approvals and the entitlements to actually build this facility. So a certain amount of low income and the rest can be at market. So there's that affordability aspect. But that in affordability, there's two things going on, right? There's the cost of the rental space, and then there's the cost of the energy component. The things that you need to do to keep the lights on and keep the apartment warm and do your cooking and things like that. So all of those energy pieces are also a challenge to affordability. And you need to be mindful of that. And what we were seeing is in looking at that affordability component, not only the drive for higher rents and needing some affordable housing. The second thing was, if you take a look at the expected growth or rate increases that have happened over the last few years and are in plans for the next few years, and looking at the utilities IRP and seeing a pretty steady 4.5 to plus percent annual growth in the electricity rates, we felt that we could do better by putting an on-site energy system in place.
Wow, that's very interesting. That really strikes me as unusual. We don't see a whole lot of multifamily housing that is on-site energy.
That's correct. That's correct. It's been done before. This one happens to be a lot more intense because of the sustainability aspects, which I'll get to. So the idea here was there's if I stick with the traditional approach of having most of the power come from the grid and having most of the heating and cooling come from a gas network, natural gas network, and those prices are not controlled and have a history of being kind of uncertain and kind of increasing every year, then, so there's an affordability or lack of affordability aspect to that.
Mm-hmm.
So trying to get a hold of the rental and the energy costs for the tenants. So that's one. Second thing, and I mentioned about being resilient in the face of a storm, and having extended outages. Ann Arbor's experienced 5-day outages. With the grid being down in the winter. So those are really risky situations for people. And so we felt that was something we need to address. So we wanted to create a shelter in place environment. In other words, if you're going to keep people out of harm's way, let's make where they are in the building safe and secure. So that also suggests that an on-site energy system is a good component for the reliability and the resilience aspects of that. And then we looked at the sustainability, and frankly, when we looked at the numbers, the grid emissions, in Ann Arbor were 2 times the national average. And we felt like, okay, so if we use the grid, we're going to have a risk associated with the resilience. We're going to have a challenge to affordability, and we're going to bust our objective on sustainability in the short term and the long term. So we had long discussions with the design team and the customer or the owner and myself about this. And the owner said, let's just go off grid. And that way we can take control of the affordability, the resilience, and the sustainability. Okay.
Interesting.
Yeah.
Off
So
off grid in the middle of a city is just not
off
something you
grid,
hear a whole lot about.
off grid in the middle of the city, across the street from the University of Michigan campus.
Wow.
Okay. So our intent was not to, create a in your face type of situation here. The idea was that when you look at the fundamental objectives and the objectives that were agreed to with the city for this housing complex, we couldn't meet those objectives without going off grid. Now,
So the numbers basically forced you to go off grid to achieve your goals.
yeah, well, and let me say this. We could have still had a grid connection, but as we worked our energy model, the amount of grid energy that we were taking was getting less and less because of not meeting those affordability, reliability, and resilience and sustainability objectives. So we were down to less than 4% of the energy that was going to be consumed at the site was actually coming from the grid anyway. So it wasn't like a big shift in how we were going to power the facility or provide the services. And people who know me, I always say, remember, the grid is just another resource. And we often put way too much emphasis on that, and that ends up perturbating designs for that meet or try to meet customer objectives. And if you just step back, take a breath and say, look, the fuel cell is just a resource, the solar is just a resource, the battery is just a resource, the grid is just a resource, and
That's very
geothermal is
different thinking.
Yes.
Very different thinking, because most people think of the grid as the resource, and these other things are kind of like
on the
the
periphery. Yeah.
right. Exactly. So you're putting them all on the same level. They're all just a resource, whether it's the grid or whether it's solar. It's all just something to look at.
Right. So each resource has a particular characteristic. There's pluses and minuses in that set of attributes for each resource. And when you're doing your design, you just pull together the things that contribute the best. right?
Mhm.
And so that's what we did. So we got to that situation. We actually went back to the city and said, "Hey, here's what we're doing, and we need you to understand why we're doing it and how." And oh, by the way, this doesn't mean that it's there's a change with the relationship with the utility. You also need to think about how you portray your building standards and your emergency standards. It understand. Let's evacuate the building if there's a fire, but if it's cold or you're in the middle of a very serious derecho or something, something that is challenging the grid and challenging the area in general, it's better to keep people undercover and where they have access to power and heating and cooling and other services, water services, things like that. So it's better
Mm.
to have a shelter in place strategy for certain sets of events and not just do a blanket, hey, in all emergencies, we're going to evacuate the building.
So did they change the rule then for this particular structure?
It's in the process, but we have the approval necessary to enact our strategy around sustainability, resilience, and affordability. So we're on the right path. We will, when the rules get updated, we'll be in compliance with those.
Was there any concern? I talk to so many people these days who are telling me about problems with interconnection. Of course, a lot of it's on the transmission grid, but also we hear about it on the distribution grid.
Yes.
Was that an issue at all with this project? Was that part of your thinking in terms
There,
of wanting to go off grid?
yeah, there was a complication that we wanted to avoid, and we were gonna avoid it one way or the other. And it's not in the state law, but in the utilities practices. And we found out through discussions with the utility that it's a practice that dates back to, and it's in their policies, dates back to 1979. So in 1979, on the heels of PURPA, which was 1978, public utility, I forget all the
Regulatory
something
something. Yeah.
act. Yeah.
uh
Power Act. Yeah. That that opened the door for independent power companies, independent power production and things like that,
Mhm.
and doing PPAs and things. They the utility put a policy in place that said residential customers can only be supplied by us. Okay.
Hmm.
So that one of the things that we didn't want to do is we didn't want to do that. We wanted to have basically a point of demarcation with the utility, an interconnection with the utility at the boundary of the facility. And that way we could design the energy system within the facility to be the most reliable and most resilient system that it could be. But the
So
rule,
are you saying that the system as you're designing it the building will the connection will be with the building, but not with each individual residence? Is
correct,
that the difference?
correct.
Okay.
If we were to have a connection, and if we have a connection in the future, it's only going to be at the perimeter. It'll be one connection at the perimeter to the utility. Okay. And their rules said that we would have to, and it was going to require 5 connections to the site. And 3 of those connections were going to have to be right of ways throughout the interior of the building to get their runs to each of the residents in all 8 floors.
Hmm.
Okay. And we said, well, that defeats the purpose of our shelter in place strategy for resilience, because when the grid goes down at 30 below in the winter time, all the residents are going to be cold and dark, and all the hallways are going to be lit and warm. Okay. And that's not a good look, not only for us as as an owner and operator of a large multifamily facility, but it's not a good look for the utility either. Okay. So that was a set of discussions that was had, and the utility was not willing to change their rules. So the owner said, okay, that's kind of like the last straw. So there's not going to be an electric connection to this building.
Interesting.
Yeah.
And is the utility resisting that in any way?
They haven't so far. And, and there's been public discussion with city council and public hearings around this build out. None of that's been raised by the utility. They are having periodic discussions with the owner just to keep track of what's going on, and they're tracking it with interest, and that's fine. We like that. We're not trying to create, an adversarial relationship. It was simply, meeting our objectives, and we couldn't meet our objectives with the utility,
Mhm.
supplying power. So a little bit about the building. It's a mass timber construction. So the platform, so call that like the first floor, is precast concrete. And there's a couple areas that are on top of that, which are like courtyard areas. And then there's two large buildings that are the residences. So it's a rectangular building. And then the other building is actually Z shaped,
Hmm.
and it all fits together, and it's just gorgeous. And the building will not only support 225 families, it also has a parking area on the first floor that is 54 spaces, and they're all enabled for electric vehicles.
Oh, wow.
And the plan is there will be some personal owned vehicles, and we hope those are electric or plug in hybrid. But then also, what we're trying to do is recognize that with 225 residences and only 54 parking spaces, then we need to think about doing like a shared electric vehicle program.
Hmm.
So that's part of the plan is that we haven't decided the number yet, but maybe there's, remember the old zip car approach?
Oh, sure. Mhm.
Yeah. So it's zip car, except all the vehicles are there in the building, in the garage. So the idea is that you can lease, short term, couple hours, couple days. You can short term lease this shared EV bank, and use that, and then you don't have to have a vehicle to live there. And then we've got a couple bike rooms and electric charging for bikes and things like that. So the idea
Mm.
is recognizing that this is downtown, and for people who live there, who live, work, and play, within a couple mile radius, why not facilitate bikes and cars, electric cars that are shared? Okay,
Mm,
so
that's brilliant. So who would own the cars? Would it be would the property owner own the cars, or would you have a third
that
party come in?
the plan is for the property owner to own the vehicle fleet, but it doesn't necessarily have to end up that way. It could be a third party, and that would, somebody providing electric vehicles as a service, EV as a service,
Mhm, mhm.
you know? So
Interesting.
and we can all do that these days, right?
Mhm. It's so great because it takes care of that problem of so many of us. I mean, I honestly my car sits there so much, never being used, you know? And that takes care of that problem. So many of us have that problem that our cars are
R
just sitting there not being used. We don't
r
need all of these cars.
Right, and how many cities do you know where you own a vehicle that's sitting most of the time, and you're paying, $200 to $500 a month
Right.
for your parking slot for your vehicle
Mhm,
to sit? And this will eliminate that cost to the tenants.
mhm.
Okay. And then, then it's like it reduces your insurance, or several things get reduced, right?
Right, it's interesting because you're not directly attacking the housing cost problem there, you're indirectly attacking it by bringing down their other costs.
That's right. We're recognizing that to make living affordable, then you need to not only work on the living space costs, but also the energy costs associated with that.
Mhm.
So,
So tell me about the energy, and is
sure.
the name of the project Southtown, is that correct?
Yes, Southtown by 4M. So 4M is the owner, okay? And they've got several other properties in the area and plans for more. We're going to upsize Southtown and build a few more just like it in the same general area, because we're putting in 225 new residences where at least 10,000 are needed. So we
Mhm.
figure there's enough drive for us to build another 4 buildings, and they'll be
Demand
larger,
is
they'll be
there.
standard. Yeah.
Yeah, I imagine this could definitely be replicated in other cities because so many cities have the same problems.
Yeah, so one of the things that's taken us a long time, and this is not a pick, or I'm not poking fun at our architect engineer team. It's everything that we've asked them to do, they've done, but it's all been new for them. So right now we're working on how are we going to transform the real estate construction industry and how they look at energy. So we're looking at how they look at energy. We're well in hand with the Southtown as an example, but the construction practices, we know it, and we're learning this from our dealings with mass timber, is that the more the things that we can do in a factory, okay, and have it
Mhm.
shipped and assembled at the site, then we know that it reduces material costs, it reduces labor costs in the factory, and then it also reduces time and labor costs on site for assembly. So we're trying to use different lingo here. We're trying to we construct things in a factory and we assemble things on site
Hmm.
instead of constructing things on site. And
Mhm.
so the team has been reading about this and we're looking at other examples. We're going to see other examples and things like that. And we know that this is a radical shift in the commercial real estate space. And we know that there's probably 50 to 60% time and cost that we can pull out of the picture by
Mhm.
taking this construct in a factory and assemble on site methodology. So that's still got to work through all of that, but you'd be surprised just how much that can change how you reflect costs into a tenant's lease. And
Yeah, I was thinking it would reduce the lease, but also would this offset some of the costs of some of the energy systems that you're putting in? I think you
yeah,
talked about fuel
yeah,
cells and
yes.
solar and Mhm.
Yeah, fuel cells, solar, batteries. So 3 fuel cells, 2 batteries, and a relatively small solar, 2 small solar arrays. They're pretty small. It's only a total of about 130 kW. And that's because we have green roof and patio areas on roofs and things like that for quality of living.
Mhm.
And there just wasn't much left over for solar. But in addition to those things, which are all things that are built, they are constructed off-site, delivered and assembled, right? So it fits the model that we're talking
Mhm.
about. So we think that there's going to be costs that'll get driven out of even the energy system that way. So this energy system, I mentioned fuel cells, solar, batteries, a carbon capture system. So we're going to capture the carbon off of the fuel cells. Okay. In
Mhm.
addition, we're using RNG, renewable natural gas, instead of fossil natural gas at this site. And so we're taking carbon out of the equation from the front end and the back end. Okay. And it also includes geothermal. And here's an interesting thing. What we when we were looking at the geothermal supply for the building, and this is we did extensive energy modeling of the building of the uses and the sources, electric, heating, and cooling. Those are the energies, right?
Mhm.
And what we found was that the traditional way to look at a geothermal system for a large multifamily is you have to you have to really protect the field balance. So you don't want to take too much cooling out, in the summer to where it can't recover itself getting ready for the next year, and you just end up diminishing the field's capability, or looking at it from a heat perspective, taking too much heat out in the wintertime and you can't recover it. So the traditional approach is balancing of the geothermal field. So kind of equal parts of cooling, in the right parts of the year, and equal amounts of heating in the right parts of the year. But in that balancing, we saw that we were actually expending about 2 million MMBTUs per year, more than we needed to. And the fuel cells have excess heat. And that excess heat, that heat is a waste heat off of the fuel cells, and therefore it has a zero carbon value because all the carbon is associated with the electric production. So that waste heat, we can take that directly to the heating loop of the building, or we can put it through absorption chillers and provide cooling to the building. So
it's kind of like a combined heat and power plant that you have in there.
It is, but it's a little more complex than that. But the point is that we now have a tool, another function, which is to maintain the health of the geothermal field. Because at the minimum energy usage, it was huge on cooling, geothermal field, huge on cooling, very minimal heat production. Okay. So it was out of balance. But if we have the tools, both from the 3 fuel cells and the absorption chillers, to supplement it with heating and cooling for maintaining the health of the geothermal field. And we can control all of that with a mixture between the microgrid controls and the building management system. We're going to be able to do that. So it's more sophisticated, as an energy management system, but it's doable. Things like that have been done before, and we're just putting it here alongside everything else. So that's taking 2 million MMBTU per year out of the source energy use of the building.
Wow.
So we moved from a little over 8 million to right at 6 million. Just things like that. And because we had this zero carbon heating that we can use from the fuel cells, we took out all of the electric supplied heaters for the building, not the residences. They still have heat pumps, but we could take out all the other electric heat exchangers, heat pump heat exchangers that were heat pumps, powered heat exchangers, supplied heat exchangers that are electrically driven, and take that out of the building. And same thing with a fluid cooler that was going to sit on the roof, and take that out because we have other sources of cooling. We have the geothermal field and we have the absorption chillers on the back of the fuel cells. So we didn't need 3 sources. So what we were able to do is we were able to further reduce the electric load of the building and the heating and cooling load of the building. It's a couple levels of optimization, in design to get to that point, and freaking people out, right? Because you're saying, okay, you're going to take all of my electric resistance heater vestibule heaters out of the building, and but we're going to use hydroponics or hydronic heating, right? So it's water, because we have plenty of hot water and we have plenty of cool water, so we can just run that in those vestibules and hallways and things like that, instead of supplementing it with electric resistance heating.
Isn't that also a nicer kind of heat to have?
It depends on who you talk to, but there's a sustainability aspect of it, there's a reliability aspect of it, and because we're using something that's basically carbon free and lower cost, there's an affordability aspect. So all of these things are working in the same direction to make this a more affordable place to live. So I think it's hard to argue, no, I want to do these traditional things because that's what I'm comfortable with. And we had those discussions. But this is, if somebody, you get a residence, let's say a grad student and his family want to move in, and they start looking at this, and they're going to say, oh yeah, this is the place for me.
Right, right. Yeah, exactly. These kind of innovations you just don't find anywhere. Hey, I want to jump back. You mentioned that you were using renewable natural gas. Is that
Mhm.
actual RNG or is it a contract that offsets natural gas that's being used?
Well, it's hard because if you were to pull a couple molecules out at the boundary of the property, it would be hard
Hmm.
to tell, you know, where they came from, if they're green or blue,
Hmm.
or black. So there is a certain amount of accounting magic, but it's no different than if you're buying solar, okay, or wind power in Texas or
Hmm.
California or Michigan, or Ohio or whatever, because they all use the same mechanism because the electrons don't know what color they are either when
Right,
they get to the
right.
site. So,
I'm a community solar project, so
yeah,
I don't have actual solar electrons coming in, but
you don't
I'm
know that.
producing. Right,
You
right.
don't know
Sure,
that.
I don't know that for sure. I don't know what's
Right.
coming in. Yeah, good
Yeah.
point.
But
Good
but
point.
the point is that there's a common carrier gas network in the state, right? And that gas network to the site is actually owned and operated by DTE Energy, so the utility. Okay. But we'll have a contract with a supplier. And our plan is to start out with DTE supplied RNG because they have RNG feeding their system from a couple landfills. Okay. So
Mhm.
landfill gas cleaned up to pipeline standards, that's RNG. But it doesn't have the negative carbon footprint like a dairy. But our
Mhm.
plan is to migrate to a dairy or swine based or food waste based RNG in a couple years, probably by 2029 or 30.
Mhm.
Okay, we just want to get the things working and getting everybody used to the process, and then we'll go upset it one more time
One
and
step at a time, right?
cut our own contract with with a group of dairy farmers in middle Michigan and that kind of thing. But we've seen just in the time that I've been involved, the last 15, 16 months that I've been involved, I've seen a doubling of the number of projects operating and under construction in Michigan, RNG projects.
Hmm. It's encouraging.
Yeah.
And then eventually hydrogen, green hydrogen.
That is eventually the case. And it's a simple transition for us with the fuel cells.
Mhm.
We would do it at the time we would make the physical change. At the time, we would be like end of life on a stack. So these stacks last about 10, a little over 10 years. The active region of the fuel cell is called the stack. And it would make sense to do a front end change to support direct hydrogen feed at the same time you would do a stack change. Okay.
Mhm.
Because the fuel cell has a front end that is taking in natural gas, renewable natural gas, and basically separating out the hydrogen that goes into the fuel cell active region, water, and the CO2. Okay. So if you just bypass that and feed hydrogen directly, there's going to have to be some purification in the front end. But you do that, then you don't have to capture the carbon anymore because there won't be any. But the truth is that we've looked at it, we've projected where do we think this will be when the technology, the movement factors, movement of the gas, and the pricing of the gas will all come together into a mature market, right? Because
Mhm.
we don't want to do it before all that stuff matures because that could add a lot of risk if we don't wait it out. But that's probably 2037 timeframe,
Hmm.
plus or minus. So we're going to be quite a while, probably 10 years on RNG before we make the decision. And then at that point, it'll probably be a financial decision to go
Mhm.
either with continue with RNG or go to hydrogen. And it'll probably be, cost of the fuel related.
Right, right. Yeah. But 10 years doesn't sound that far away really when when you think about what's happened in the last 10 years. It just seems like the energy in the energy world, 10 years isn't a long time.
It's not. It's not.
Yeah.
Yeah,
So,
I've been
uh
doing these on-site energy systems for 20 years, and some days it feels like it was just yesterday.
it's so incredibly true. Let me ask you, have there been any particular hurdles you've faced so far in this project?
Nothing that we couldn't solve. There wasn't any like insurmountable things that we had to get some special dispensation from the Pope to continue. But I will tell you, there's been a lot of education and there's been a lot of angst that we've had to work through because of not having a grid connection. There's just because the whole industry and even with on-site energy systems, they just want to rely on that grid connection.
Mhm.
And if it's well, we can do this battery and then we'll add the battery and then oh wait a minute, there's no grid connection, so maybe we should have two batteries. There's just a lot of things like that because of being off grid that we had to be mindful of. Now, it's not like we shouldn't have known that already, because when you take a look at all of the places in Alaska and upper Canada and island nations and that who've all dealt with not being connected to the grid, it shouldn't have scared us, but it did. So we've had a lot of discussions around what are our risk scenarios? How does it change our emergencies? How do we do our transient analyses not connected to the grid because we don't have that thing that we can rely on, even though you probably shouldn't have been relying on it anyway? Because at the end of the day, we're a 4 nines operation bordering on 5 nines,
It's
and
impressive.
the grid is a 3 nines operation.
Mhm.
So it it when you put it in the mix, it actually doesn't increase the reliability, it actually reduces the reliability.
If you're
And
grid connected.
if you're grid connected, that of course assumes that you're designing everything properly. But the point is that just some of those mental models we've had to really challenge and had to work through to make sure people were thinking about it in a complete fashion, not in a limited fashion based on traditional thought.
Right. And
The-
and it's unusual, but it's not unheard of. Like you said, it
that's
happens in
right.
Alaska.
That's correct. And I think places like California, you're going to see a lot more of that because many would argue that the prices are out of control in
Mhm.
California, and that's the quickest thing to drive people to different, radically different solutions than their traditional approach. The other thing that was a challenge is that we had to change our thinking a little bit about the energy model and how to model this whole thing. Typically, when you're building a building, they use this. They use a couple of the standard approaches that engineers use, which are really based in capacity, not based in energy. And so they do this, connected energy or connected electric model, which is I add up everything that's connected to my distribution system in the building, and that's how much capacity I need.
Mhm.
Yeah, well, this building would be close to 4 megawatts if we did that, but we would never use that. In fact, we would probably be at 900 kW. Okay, but that's the approach, right? So you end up over designing everything. Well, you can't do that when you're looking at the energy assets that actually generate electricity, because if I put 4 megawatts of fuel cells on that site, A, I wouldn't have room for it. B, I would be running them all at 25%, you know,
Mhm.
output. So that's just not economically viable at all. We had to really collectively teach the whole team how to look at the energy model differently. And we went through a bunch of interviews and well, how okay, so this thing that you say is 250 kW pump, well, how often does it run? Well, it's going
Mhm.
to run about 15 minutes every 4 hours. That's good to know. So as an average load, it's going to be about 15 kW, not 250.
Interesting.
Okay. So we design, now you have to have knowledge of what's going on, right? So then you have to say things like, okay, we're not going to have it running that peaky load. We're not going to have it running the same time we have other peaky loads. Right? So there's going to be some rules within the building management system that say, there's 3 or 4 things that really shouldn't operate simultaneously, that kind of thing. So that's just one example. So what we had to say was, here's the building model. Here's the energy system energy model. And here's the geothermal energy model. And then we had to marry those things and then do some horse trading between those 3 elements to say, this is how we should end up operating the building.
This is fascinating because I'm thinking we talk about this kind of from the other end a lot, right? We talk about, okay, now we have all these systems in the building. How are we going to manage the load, manage the usage so that things are, running in an optimal way or an energy efficient way, or, or we're reducing the peak. But you're coming at it, I think, from another angle. You're saying we're actually going to be not just managing it. We're going to embed that in the design.
Yes.
So that we're not overbuilding anything. We're actually looking at how much we're going to actually use, not what kind of the nameplate on some piece of equipment is that it uses, what it actually uses and when.
That's correct. So we did all of this based on interval data. And frankly, after going through all of that, I think that's the way we need to be looking at things in the commercial real estate, multifamily area. I think we have a tendency to I think there's a lot of extra costs in these buildings based on 1 hour a year. And it's better for us just to eliminate that 1 hour a year. And we can do that operationally.
That's fascinating. So it's sort of analogous to what we've done with the grid, right? We've built it to the 1 hour a year rather than thinking rather than using a more efficient model.
Yeah,
Yeah.
that's the 100-year energy model that we've been employing in every aspect of our electric system. Front of the meter, behind the meter, doesn't matter. We all do that. And in fact, all of our statutory standards force us in that direction. So in the past, we could do that because the prices were cheap and everybody overbuilt, so there wasn't much of a resilience or reliability challenge and things like that. We didn't care about sustainability. But now that we are caring about all of those things, we can't afford the result doing it the way we did in the past. We just won't be able to afford it. So we have to get smarter about how we integrate our objectives of affordability, reliability, resilience, and sustainability. You just have to do it.
Very interesting. So I'm going to ask you one last question. You've been in the DER business for a lot of years, and you've broken a lot of new ground, and you are doing it again in terms of technology, business models. I hear from a lot of newcomers who are heading into the space, and they're entrepreneurs, investors, job seekers. What advice would you have for them in terms of what's ahead? What does Steve Pullins see as sort of the next big thing in energy that they should be focusing on?
I think this nexus of what are we going to do with buildings? Buildings represent 38% of our carbon footprint in the world. And buildings, because of the continued urban migration and that, World Economic Forum put out a study in January 2022 and showed that we're going to go from 220 billion square meters of floor space in 2020 to 440 billion square meters of floor space in 2060. So over that 40-year period of time, we're going to double our floor space in buildings. And if you take the power sector to zero carbon footprint, and you take the transportation sector to zero carbon footprint, the carbon footprint still grows in the world. in the US and the world because of the buildings space.
Because you're adding so much more. Yeah.
We have to change the rules about how buildings are built because the average building lasts 85 years. So this next 20 years, if we build all the buildings the way we built the last 20 years, we're going to be stuck with, 2.5 degree, 3 degree,
We're in trouble.
warming for 85 years. Okay. That blows everybody's models. Okay.
Yeah,
So we
sure
have
does.
to change that. We have to change that. So that's a big thing. The other thing is, and I'm kind of on a cycle right now and I'm pushing a thing called demand flexibility. And one of the things I learned, traditional building wise, if you look at what's the margin in which I can move things around and make the building a flexible demand node on the grid, it's about somewhere between 4 and 20%. I can play
But
with.
just describe for 1 second to everybody what demand flexibility is, because I'm not sure everybody knows. It's a fairly new term that's being used.
Well, it's a new term in the US. It's not new in Europe. It's been discussed for 10 or 15 years in Europe. But it's the point of making the customer side of the meter more flexible as a resource for the grid. Okay. Well, it turns out there's also demand flexibility advantages for the customer to have more demand flexibility. Okay. But the idea is flexibility in how they manage their electric load. Okay. So that 4 to 20%, you can take that to about 80% demand flexibility. So 80% of your demand can be flexible as far as how the grid looks at it if you put an on-site energy system in place with that building. So it greatly improves the ability to flexibly move energy needs around behind the meter, and that can be used for cost savings for the customer or the owner. And it also can be a really large asset for grid services if at some point in the future, behind the meter assets get properly rewarded in grid services. Right now, you can make $50 to $100 a year on grids, on grid services from a behind the meter resource, and
that's ridiculous.
it's just not there, but if that happens, this will be a really good resource behind the meter, especially buildings, be a really good resource to support the grid's stability and sustainability objectives and things like that.
Interesting. Very interesting. Well, good. Well, Steve, thank you so much. As always, this was really fascinating. I also have to say, you are a very good friend. You took on this project for a friend.
Yeah.
And you may just be like changing the way a lot of people look at energy in the United States as a result. So,
well, we have, with this project, we've developed a core team of evangels who really see this as that it has a big upside potential as far as changing the way we integrate energy, sustainability, and reliability or resilience. So we are gung-ho on this and making that change.
Wonderful. Well, keep us posted on this building. We'd love to hear about when it goes live, when people start moving in and how it all goes.
Yeah.
All right. Well, thank you, Steve.
Sure.
Thank you for joining us today on the Energy Changemakers podcast. I hope today's conversation has inspired you to think differently about the role of distributed energy in our society. If you enjoyed this episode, please subscribe to our podcast on your favorite platform and consider leaving us a review. You can help us shape the dialogue around energy. Go to energychangemakers.com, subscribe to our newsletter, and join our community. Together, we can make a real difference in how quickly we can make our grid local, equitable, and clean.